Jai Hind students. In the series of complex topic of telemetry principle, now we are going to concentrate on unit 5th, and today we will basically going to study about basics of satellite telemetry. Actually, when you are talking about telemetry, telemetry means remote location. Whenever your sensor is located at remote location and you want to access the data of that sensor or you want to collect that data, in that case telemetry is required. Telemetry means tele plus metering, means measurement at the long distances. So when this satellite communication came into picture, that is basically used when the distance between the transmitter and receiver is more than 1500 kilometer. In that time, normal line of sight communication is not well enough to do the communication task. That's why satellite communication came into the picture. Similarly, in telemetry, you are going to access the data from the remote location and you don't know the actual distance between the sensor location and the ground station or the earth station. That's why that distance between them is maybe more than 1500 kilometer, and in that case satellite communication or satellite telemetry came into the picture. So before starting the satellite communication, first of all we will going to study about the what is satellite. As you all know that moon is the natural satellite of the earth, and when we are talking about the artificial satellite such as India's first, that is Aryabhatta, that satellite is a actually man-made object which rotates around a bigger planet or bigger object to collect the data in form of communication or something else. So that is basically satellite. So when we are talking about this satellite, so basically a satellite is a physical object that orbit or rotate about some celestial body, and the satellite occurs in nature, and our own solar system is a perfect example, such as Jupiter having the natural satellite as many satellite as Titan and other one. The Titan is the satellite natural satellite of the Saturn, and so these all are satellite launched and orbited for a variety of purposes, and the most common application of is the communication, in which the satellite is used as a repeater circuit, because when we are sending the data from transmitter to receiver for a long distance, so as soon as data travel through the atmosphere or the space, noise will be add up, and that addition of noise will distort the signal. That's why at the fixed spaces or fixed distances repeaters is required. What is the basic function of a repeater? That repeater is just taking the incoming signal and then performing the filtering and amplification, and again transmitting back it in the required direction. So that is the simple function of a receiver. And when we are talking about a communication satellite, that is an orbiting artificial earth satellite that receive a communication signal from a transmitting ground station and amplify and possibly process also, and then retransmit it back to the earth station or the another user which want to require that signal. So this is about the satellite. Then this is the basic diagram of a wireless satellite communication system. In this satellite diagram you can see that this is the satellite part. Here this is the user data. That user data is coming from various points such as your mobile phone, your some television broadcasting center or something else, and that data is going to the base station or the gateway. Basically this base station or gateway is directly connected with this satellite. So that satellite, the signal is going to this satellite, and then that data is coming back to these cells. As you are talking about the mobile system, you are using the GSM. In GSM you are using a cellular cell. In the cellular cell, what is there are complete earth is divided into the hexagonal shapes, and these individual shapes are known as the cells, and each cell have its own BTS. That BTS is base transceiver station. So this base transceiver station is connected with the satellite and with the earth station या mobile or the mobile switching center. In the case of mobile switching center, mobile communication, this satellite communication can be used. So basically this is the general diagram of a satellite communication. You can see that this is the base station or gateway. These are the ISDN, PSTN network, GSM network, and these all are the users. That users are directly connected with this satellite link, and whole complete system is divided into some small cells. So this is about the wireless satellite communication system. Then how do satellite communication works? How it is going to work? This is the satellite which is placed in the orbit, and this is the earth station which is the transmitting earth station, means this is earth station is sending the data. Similarly, this is the receiving earth station. Now here you can see that this data is sending towards the satellite on a link. That link is known as uplink, and this link have a specific frequency that is known as uplink frequency. Similarly, another is a link which is for responsible for the retransmission, and the receiver earth station will connected with this satellite through this downlink, and this downlink also having a frequency which is known as downlink frequency. In the satellite communication, uplink frequency is always greater than the downlink frequency. Why this is happening? Because there are certain reasons. That's why in satellite communication we are taking the uplink frequency greater than the downlink frequency, and that reasons are basically, first one is power supply, second one is attenuation. Power supply, actually for the transmission of higher frequency or the generation of higher frequency, large power, so high power sources are required, and at the earth station it is possible because you are at the earth station and as much as power you can generate, but on the satellite you cannot generate enough power for these high frequency signals. That's why we are using higher uplink frequency rather than lower downlink frequency. Another point is related to the attenuation. When this signal sent to the satellite, in that case it is going to penetrate the atmosphere, and due to the another conditions of the various propagation effects, attenuation will take place as soon as the signal leaves the earth outer atmosphere. That's why higher frequency signal is also required. So this is the reason, that's why uplink frequency is always greater than the downlink frequency. In mobile communication there is just reverse. In mobile communication, downlink frequency is greater than the uplink frequency. That is another point of concern. So now in this satellite communication, two satellite station are on earth station want to communicate through radio broadcast, and the two station can use a satellite as a relay station for that communication. One earth station send a transmission to the satellite, that is called uplink, and another one is known as the downlink, and satellite having its own transponder. Basically transponder is what? Transponder converts the signal and send it down to the second earth station. So you can also call the transponder is just a repeater, that as it is receiving the signal from the earth station on uplink frequency, then going to process that process the data, or going to remove the noise and amplify it again, and then transmit it towards the second earth station on the downlink frequency. So this is the way this satellite communication work. Then the advantages. So basically satellite communication having the advantage of the coverage area of a satellite greatly exceed that of a terrestrial system, because I told you more than 1500 kilometer it is required that we should use this satellite communication, because more than 1500 kilometer line of sight is also not possible, and another propagation such as ground wave propagation, space wave propagation are also not possible. Then the transmission cost. That transmission cost of a satellite is independent of the distance from the center of the coverage area. That is also a very important advantage. Then satellite to satellite communication is very precise. Also higher bandwidth are available for use. So these are the some advantages of satellite communication which make it more reliable in these days. Then types of satellite, it is also very important, because for the various application we use various kind of satellites, such as you can see in the last days Starlink satellite that are placed in the LEO orbit, means lower earth orbit. So when we are talking about the satellite types, then basically there are three basic orbits: LEO, MEO and GEO. LEO stand for lower earth orbit, MEO for medium earth orbit and GEO for geostationary earth orbit. Again this geostationary orbit are two types of, first one is orbit and another one is GSO, geosynchronous orbit. So when we are talking about these orbited, other than that there is also another one which is HEO, that is hyperelliptical earth orbit, in which this orbit the satellite will rotate around the celestial object in a elliptical path, and the apogee and perigee point can be vary as per the requirement of the application. So when we are talking about the LEO, MEO, GEO, the LEO height is 500 to 1500 kilometer, whether MEO height is 5000 to 12,000 kilometer, but when we are talking about GEO, that is 35,800 kilometer. And when we are talking about the orbital period, GEO orbital period is 24 hours, means it is just equivalent to the earth rotation period. That's why geostationary satellite always seen stationary with respect to the point located on a specific point with respect to the earth. That's why in geostationary satellite we are using for maximum for the communication purpose. Then satellite subsystem. Now this is the part which is basically connected with the telemetry part. How it is going to connect? Now you can see that. In the first diagram you can see that this is the satellite. In this satellite there are various parts, because when we are talking about a satellite, satellite is not only about a simple system. Actually satellite is a combination or combination of various subsystems. These subsystems are different part of a satellite which are responsible to perform a specific task, so that we can achieve a final object through this satellite. You can see here these are the solar panels. As you know that solar panels are used for the power supply purposes. This is the encapsulation of the satellite. Here this is the antenna for a satellite which is going to be used. So you can see that there are various blocks. So when we are going to classify this various blocks for the satellite, then these subsystems came into the picture, and these subsystems are attitude and orbit control system, TTCM means telemetry, tracking, command and monitoring subsystem, then power subsystem, communication subsystem and satellite antennas. So starting from the attitude and orbit control system. So when you are talking about attitude and orbit control system, this is your earth, here it is your satellite. This satellite is rotating in this path. Now let it is a geo satellite and its height is around 36,000 kilometer. Now see, as per the orbital parameters of this satellite, the attitude of the satellite is 36,000 kilometer, whether orbit positions are defined by the orbital parameters, orbital elements. So attitude and orbit control system is basically designed, and it is a main part of the satellite which control the attitude and orbital element of a satellite. Means if any satellite is losing its attitude, means due to some reasons satellite is falling down. In that case, your height will be decreased and the functions which is associated with the geo satellite cannot be completed. So in that case, attitude control system is required, which is going to maintain this satellite in its path. So how it is going to work? As you know that when you are taking a simple example in your childhood, sometimes you are just tying a stone with a thread and you are going to rotate that thread with the stone in this circular motion, and you can see that when you rotate this thread and stone, this stone with the thread, your stone will rotate around you in a circular path if you are maintaining a fixed velocity. If you are creating more velocity or generating more velocity, then in that case your stone or your thread will be broke and that stone will be go in the tangential direction. But if your speed or velocity of the stone rotation is less than the required one, then your stone will not be able to rotate in the circular motion and it will fall down. That same concept is applicable here. In this case, your geostationary satellite is maintaining a speed and that speed is around related to the is this orbital period. You can see here for the geostationary satellite, its speed it is creating the 24 hours to cover up this complete section, and anyhow if this satellite is taking more than or less than 24 hours, means this satellite is losing its attitude. Similarly, to maintain this satellite velocity, we are using some boosters on the satellite. That satellite boosters or the rocket thrusters will be on when its velocity is going down or increasing. In that case, that thruster will provide the required thrust to the system and that will maintain again its velocity. Similarly, orbital parameters. As you know that for general orbit for any coordinate system, you are using the just Cartesian coordinate system x, y, z, and this is giving the location of a point in a particular coordinate system. Similarly, to record the location of a satellite into the orbital into the orbit, you required the orbital parameters, and orbit control systems are related to that parameter. If any one parameter of that satellite orbital parameters is going to change, means satellite is not in the orbit. That's why the various thrusters or flywheels are also available on the satellite in each direction, such as these are the three direction, and in the nomenclature of satellite communication system, they are actually using yaw, pitch and roll direction, such as x, y, z. In these three direction, they are actually using, this is the yaw, pitch and roll. They are using actually three set of flywheel motors or thrusters, each in opposite direction. Means in yaw direction, one thruster is in this direction and another one is in this direction. Means if satellite is losing its orbit, means whether it is going in the upper direction plus or yaw direction or negative yaw direction. So when satellite is going in one direction, another side thruster will be on and that will maintain the satellite again it's in orbit. These thrusters are just giving the burst, small burst that are going to maintain the satellite orbit. So this attitude and orbit control subsystem are actually related to the satellite subsystem. Similarly, power system is related to the power supply of the system, and in the satellite subsystem, we are actually using the lithium ion batteries and solar panels for the power purposes. Communication subsystem, we are using the transponder. There are various type of transponder such as single conversion transponder and double conversion transponder, and various antennas which are basically microwave antennas that are used for satellite subsystem. But when we are talking about the telemetry, this is the most important part of the satellite subsystem, that is TTCM. What is TTCM? Actually, TTCM is telemetry, tracking, command and monitoring subsystem. The telemetry, tracking, command and monitoring subsystem is actually the most important part of a satellite. Without this TTCM system, the satellite will not work in the orbit and it will not meet the expectation of the project. So, how it is going to be done? So, when we are talking about there are 4 words. First one is telemetry. What is telemetry? As I told you, telemetry means tele plus metering, means measurement and at long distances. This satellite is actually having various sensors. That sensors may be power sensors, that may be flow sensors, that may be temperature sensors, that may be pressure sensors. These all sensors are actually giving the information about the satellite health, and the earth station is continuously taking that telemetry data from the receiving antennas from this antenna, as this satellite sensors are generating the data such as temperature of the satellite. Your satellite is orbiting around the earth. When your satellite is in between the earth and the sun, the temperature of satellite is very high. But in the same case, that same satellite, when that is in the blind spot, or we can say that in the eclipse period, means when the satellite is in the shadow of the earth, in that time the temperature will go down very low. So in that case, you have to maintain the temperature of the satellite. That's why the temperature sensors are required on the satellite to continuously monitor its temperature, and that data is going to be analyzed and processed, and similarly command will be generated as per the data. So that telemeter data is going to transmit from satellite TTCM antenna to the receive station. Then that data is coming to the telemetry receiver, which is going to receive the data, and after demodulation it is given to the data processor, and data processor is actually going to create the required data so that necessary action can be taken in this controller and the processor part. Similarly, second point is tracking. Tracking is actually related to this attitude and orbit control system. In tracking, you are actually tracking the satellite location, means you are getting the orbital parameters, the height of the satellite and all that points. For that requirement, actually you are using this tracking data, and in this tracking data you are taking these all satellite tracking data from the satellite, and that data is coming to this tracking system. This tracking system is going to analyze all this data, and that data is going to this normal controller process. Now, as per this telemetry and tracking data, commands will be generated through this controller and attitude orbit control system, and that data is going to the command transmitter, and command transmitter will create that data to this transmitting antenna and giving to this satellite again, and the satellite thrusters or flywheels can be on and off, another sensor can be on and off, and all that decision will be going to taken up. So in this complete process, you can see here the how telemetry is going to be done and how this satellite is going to be used for the telemetry purpose. So in that complete case, you can see that this complete telemetry, tracking, command and monitoring is came into the picture. This is the another simple diagram for the same purpose. In this diagram, you can see that you are using two antennas. Again, I want to tell you, sometimes single antenna is also used for this telemetry for this TTCM system. These antennas are basically the microwave antennas. In this microwave antennas, most common and popular which are going to be used are parabolic reflector antenna, then phased array antenna. Phased array antenna is just a set of similar antennas to increase the directivity and the gain. Horn antenna. These all are the various antennas and dipole antenna. These all are the antennas which are used by the satellite communication. Then the same telemetry receiver, here tracking system, data processor, and this is the computer for attitude and orbit control, and it is creating the data which is going to create the command, and telecommand transmitter is going to transmit the data. So about when we are talking about this telemetry tracking and monitoring, it collects the data from many sensors within satellite and send this data to the controlling earth station. Several hundred of sensors are located on the satellite to monitor pressure in the fuel tank, voltage, current in power controlling conditioning unit, current drawn by each subsystem, and critical of voltage and current in communication electronics. Similarly, the sensor data and the status of each subsystem are reported back to the earth station by telemetry system. So telemetry data are digitized and transmitted as phase shift keying of low power telemetry carrier using the time division multiplexing. Means when you are talking about the modulation scheme for the telemetry, that is PSK. At the controlling earth station, a computer can be used to monitor, store and decode telemetry data, so the status of any system or sensor can be determined immediately. Similarly, in tracking system, number of technique can be used to determine the current. First one is velocity and acceleration sensor on the satellite can be used to establish the change of the orbit. Also, the earth station controlling satellite can observe the Doppler shift of the telemetry carrier to determine the rate of which range is changing. Also, active determination of range can be achieved by transmitting a pulse also. So these all are the various tracking mechanism used by the satellite system. Similarly, command. The command system is used to make change in attitude and correction to the orbit and to control the communication system. So during the launch, actually they are using to control firing of AKM, apogee kick motor. AKM stand for the apogee kick motor. Means these motors are basically spin up spinner or extend solar cell and antennas for 3-axis stabilization antenna. So what is the meaning of this apogee kick motor or AKM? Actually, when your satellite is rotating in the orbit, this is the earth, one point is nearby the earth and another one is up in the distant point. These are known as I told you, you can see here, apogee point and perigee point. Perigee point is just the near point of the earth from the satellite orbit, and apogee is the long point. So when the satellite is or orbiting in this orbit, it will, when it came into at the apogee position, apogee kick motor will provide the necessary thrust to the satellite to maintain its velocity. So this is the use of that apogee kick motor. Then command structure must possess safeguard against unauthorized attempt to make change to satellite operation. Also, encryption of command and response is used to provide security to the command system. Similarly, after monitoring, all the data command are generated at control terminal of the computers. Also, if it is found correctly, an execute instruction will send to satellite, and this entire process will take 0 to 10 seconds, but minimize the risk of enormous erroneous commands causing satellite malfunction. So you can see here, this telemetry tracking and command system is actually the heart of this satellite communication, and it is going to actually provide, it is actually providing the conditions for a satellite to work in a exact manner, and so that it can achieve the targets of the project. So as I told you, these are the satellite antennas: wire monopole, horn antennas, reflector antennas, antenna array. So these all are the satellite antenna. So in the university examination, you can see that these all are the basic question related to the satellite subsystems, and the most common question is about the TTCM system. Other than that, satellite earth station subsystem is also a important topic, in which you are going to make this satellite earth station, which I already told you in the another my lectures of the telemetry subject. So these all are the basic questions of the satellite telemetry, and these are the main parameters of the earth station. So till then, thank you.